After going through this video, you will be able to explain DBMS, explain SQL, start MySQL using XAMPP. We all have created an account either on Gmail, Facebook, Instagram, or any website. So, while creating an account, we usually fill the sign up form to enter user information like name, gender, email ID, mobile number, password, and related information on the sign up page of the website. And once we create an account, the next time we want to log in, we just need to enter the email ID or username and the password. And the remaining information which we have entered earlier, we can view it under our profile or account setting. This means the information which we entered earlier is stored somewhere. Do you know where all this user related information is stored? The answer is database. Now that we understand the term database, let us understand the next associated term, that is DBMS or Database Management System. Well, DBMS is a software application which is used to store all the user related information. To be precise, inside a DBMS, we have a database. So all the information that a DBMS stores is actually stored inside a database. So if we want to access or store information in a database, it always has to pass through the DBMS. We cannot directly access the database as such. Sometimes informally, the DBMS is referred to as database. Now that we know a bit about DBMS, let us understand why we need a DBMS. Well, the DBMS ensures that the data we store in a database is highly secured and stored in an organized manner. Also, it allows us to fetch the data easily. We will learn more about it as we go along in this module. Now, DBMS also acts as a server and helps in storing and managing user data. And the corresponding client can be any software or any PHP code that needs the data. We will understand more about this client in detail when we study PHP in the next module. It even follows the client-server communication relation. Although we have studied in detail the steps involved in client-server communication, let us once again revisit the communication with DBMS acting as a server. So, the communication starts with the client who needs to store or retrieve user information. The client will then find a relevant server, which in this case is the DBMS. The client will then connect with the DBMS so that they can communicate with each other. The client will then send a request to the DBMS to retrieve the requested data. The DBMS, based on the client's request, will fetch the data from the database. And once the data is fetched, the DBMS will send the response to the client. Now we have seen the overview of how a client and DBMS communicate with each other. Let us explore the communication in more detail. To communicate with a database, we cannot simply use normal English phrases and expect a machine to understand and comprehend. There is a specific language, SQL, that is structured query language, which is a standard interactive programming language used to communicate with the DBMS. So basically, all the requests DBMS receives from a client to fetch or retrieve data from the database must be in the form of SQL queries. We will learn more about the SQL queries later in this module. Moving forward, some of the most commonly used database management systems are MySQL or Oracle. We will be using MySQL as it is widely used by the web developers community and is available for free. Here is a quick question for you. Are SQL and MySQL the same thing? Take a moment and try to come up with an answer. If your answer is no, you are right. SQL is a language while MySQL is a DBMS. No matter which DBMS we are using, that is MySQL or Oracle or some other, SQL is always used as it is a universal language to communicate with the DBMS. Let us see how we can install MySQL in Windows OS. For Windows, we don't need to install any software. It is integrated into the XAMPP, which we have already installed. To run or start the MySQL server, we need to first open the XAMPP control panel. First, we need to start the Apache service. Next, we can see the MySQL button. We need to click on the Start button corresponding to it. If prompted, a dialog box will pop up asking for access. Click OK to give access and this will start the MySQL service. Once the service starts, click on the Admin button next to the Start Stop button. This will open the client, that is PHP MyAdmin, on our browser. Here, if we check the URL, we can see the local host. If we don't start the Apache service, we won't be able to open PHP MyAdmin on our browser. PHP is a MySQL client through which we can interact with the DBMS. that is the MySQL server. In the next video, we will see how to install MySQL in Linux OS. After going through this video, you will be able to install MySQL on the Linux operating system. Like Apache, installing MySQL in Linux OS is simple and fun. So let's see how we can install MySQL in Linux OS. First, you need to open the terminal by pressing the Ctrl-Alt+T. Next, enter the command sudo apt get install MySQL server. You can also copy and paste this command from below the video. This will install the MySQL server along with a client where we will type our SQL queries to interact with the server. If prompted, you need to enter the MySQL login password and then press Y for confirmation. Well done! You have successfully installed MySQL on your system. Now for some users, while installing MySQL, an intermediate screen might not appear where it will ask you to choose a password. In such a case, you have to explicitly set a password. But make sure you note down this password and it will be used in future. To set this password, there are a few sets of commands that need to be executed carefully because if anything is missed, things may not work properly in the future. So, let us see how you can install MySQL in such cases. First, open the terminal, then enter the command sudo MySQL secure installation. You will be asked to choose a password and its intensity. Choose the options as per your convenience and you can simply replicate the steps as shown in the video. This will install the MySQL on your system. Once you have installed the MySQL, to start the MySQL client, enter sudo MySQL. Now in the MySQL Center, select User, Authentication String, Plugin from MySQL User. This is important, so please notice carefully. You need to check the plugin corresponding to the existing rows. It should be either MySQL native password or caching SHA2 password. In my case, it is caching SHA2 password. So I will use this plugin in my next command. And if in your case it is MySQL native password, you can replace the caching SHA password with MySQL native password while entering the query on your system. Now enter the command alter user root at localhost identified with caching SHA2 password by new password. Again, this command is important, so please pay attention. Here we are setting the password for MySQL root user. I have added new -password as the password which you can change and enter in your system while setting the MySQL root password as per your convenience. Please note that here you need to choose a password that is strong. That is, it is a combination of letters, both uppercase and lowercase, includes special character and a number. Note down this password somewhere for future reference and use. Also, this password does not need to be the same which you have set with MySQL secure installation. Once you have set your MySQL password, you need to enter the commands flush privileges followed by quit to come out of the MySQL client. Next, you need to stop the MySQL server and for that enter sudo service MySQL stop. And then to again start MySQL, enter sudo service MySQL start. There you go. You're all set to use MySQL. So in this video, we have installed MySQL and we have the MySQL root password which will be required every time you log into your MySQL client. As you will be using these commands only once, I would recommend you to copy and paste these commands from below the video. In the next video, we will see how to install MySQL on Mac OS. Hi, welcome to another exciting video on how to do web development on mobile. In this video, we will install another application, a web server through which we can execute SQL queries to communicate with the database using your mobile. To install this application, open your Play Store and enter a web server and install the application. Open the application and this is the first screen you will see. Here, we can see some options. Click on the Start button next to Service. This will start the web server. Please ignore the ads if they pop up while starting the services or shifting through tabs. Just click on the cross icon, or you may have to wait for a few seconds to close them. To check if the web server is running or not, click on the IP in the address section. This will open a new page in your mobile browser with the content it works. This means that your web browser is working fine. Next, at the top of the application, click on the MySQL icon, which is in the third place. Here also, we need to start the service by clicking on the Start button. Now, to open the phpMyAdmin, click on the link in the admin section. This will open a phpMyAdmin page on your browser. Notice here it will ask for username and password. Enter root in lowercase in both the fields and click Go. Congratulations, you have successfully logged into the phpMyAdmin page. Now, it's time to run a few SQL queries. Click on the SQL tab at the top and enter Show Databases, SQL query. Please note that all the SQL queries end with a semicolon, so don't forget to add it. Click on Go to Execute Query. There we go. You can see all the default databases present in the database. Let us create one database of our own, and for this, enter Create Database Demo and click Go. Let's click on this Databases tab. Here, you can see that the demo database has been successfully created. Similarly, you can execute all your SQL queries like this in the future. Before we end this video, here is one important thing that you need to take care of every time while working on this application. If you minimize this application, the services will stop automatically. Let me quickly show you. So, you can see right now both the services are in start state. If I minimize the application and again go back to the application, the services are automatically stopped. This means you have to start the services every time you minimize the application. Well, that was all about executing SQL queries on mobile. You can now use this method to practice executing SQL queries on mobile as you learn about them in the upcoming topics of this module. Hope you had fun. Bye-bye. After going through this video, you will be able to explain how data is stored in a database, list down good practices to follow for creating a table to store data in a database. Welcome back to the second topic of this module. In the previous topic, we learned that the data is stored in a database. Now, this data is always stored in the form of a table. A table is nothing but an arrangement of data in rows and columns. Let's say we have this table students_CSE where the details of the students present in the computer science engineering or CSE department of a college are listed. We can see that the table heading consists of various information such as name, UID and gender. Similarly, we have another table faculties_CSE where we can have details about the faculties who are teaching in the CSE department. We can have another table named classrooms_CSE that stores the information of rooms that are available for theory and practical classes. In the same way, you can think of other tables, but for now, let us focus on these three tables that I just talked about. All these three tables have information specific to one thing, that is, a particular college. Hence, they all are stored in a single database, college. So, let us take this table as a reference and understand a few terminologies related to it. Now, the columns present in the table are called attributes as they specify the kind of information they store. For example, the attribute name will only contain the names of the CSE department students. Next, the rows in a table are called records that represent a particular entity. For example, here, this row represents one instance of one specific student. The attributes must be defined at the start while creating the table. Whereas records can be added as and when they are ready. For example, when new students arrive in the department, we add them as a new record. While storing information for each row, the attributes takes care of which information would go in which column. This makes the entire data organized and easy to fetch. Let us further expand this example to understand how the data is stored in a database. Suppose this time you want to store information of all students of a college studying in various departments. The information can be their name, registration_number and gender. Pause the video and think about how would you store this information using a table. You might have thought of creating different tables for different departments, such as a table for civil engineering, another table for mechanical engineering, and so on and so forth. But this approach is not the best way to store the information. We don't need to create separate tables for different departments, as the kind of information we are storing is the same for each student, like name, registration underscore number, and gender. We can in fact store the information of all the students belonging to various departments into a single table students. This table will have one more additional attribute, department. Now let's say we want to store the information of teachers, such as their name, email, and designation. Do you think we can add the information of the teachers in our existing table students? If you guessed no, you are right. To store the information of the teachers, we need to create a new table because the kind of information we store for teachers is different from that we would store for the students. For example, for teachers, we are storing email and designation, which is not present in the case of students. In the same way, if we decide to store information for classes, we will follow the same concept. And all these tables can be stored in the same database, college. Now, let us have a look at a few conventions and good practices that are followed while creating a table. First, table name should be in lowercase, example, students, faculties underscore CSE, etc. Second, we should use the plural form of a noun while naming a table. For example, students underscore CSE, classrooms underscore CSE, and so on. Next, if the table name contains more than one word, we should separate them using an underscore. Example, students underscore CSE, etc. Fourth, the columns or attributes name should also be in lowercase. Example, name, designation, etc. Fifth, the attributes name should be in a singular form. Example, name, phone underscore number, etc. Next, if the attribute name contains more than one word, we should separate them using an underscore. Example, phone underscore number. Lastly, as a practice, we add an additional attribute named ID in each table that contains auto-incremented integers. We define this column as the primary key for the table. We will learn about primary keys in the upcoming topics, so don't worry at this moment. I hope now you have understood how data is stored in a database and what are some good conventions that are followed by web developers. Make sure you give a thorough read to these conventions as we will be following them throughout this training. So up next is a quiz. All the best. After going through this video, you will be able to execute various SQL queries related to database using MySQL. In the first topic, we learned that SQL queries are used to communicate with a database. And in the previous table, we took the example of the college database and the students table to understand how the data is represented in case the data needs to be stored in a table. Now, if we want to communicate with the database and edit, store, or delete the content inside it, we have to use SQL queries for three different categories. The first category is databases, the second category is tables, and the third category is records. Let us first understand various SQL queries used for each of these categories one by one. We will start with the one that deals with the databases. To write and execute any SQL query, we need an interface that recognizes and executes them. Like, for example, we have a VS Code editor that recognizes HTML, CSS, Bootstrap, etc. Similarly, we need an interface that recognizes SQL queries. So, where can we find this interface and how can we access it? Well, you don't have to worry about it as we have already set it up in our systems. For the Windows operating system, remember while setting up the local environment, we installed XAMPP. So, using the XAMPP control panel, we can access the interface that will allow us to execute SQL queries. So, we will open our XAMPP control panel. Here, we can see several services, but for now, we are only concerned about the Apache and MySQL services. Apache, as you can recall, will help us to execute the code locally, and MySQL will take us to the interface, also called as MySQL client, where we will execute SQL queries. To use this interface, we will first click on the Start button and then the Admin button next to MySQL. And the users who are using Ubuntu, you can start the MySQL client by typing MySQL u root p on the terminal. You can copy this command from below the video, but make sure that your Apache is running.
This will ask for your MySQL password. Enter it and this will take you to the MySQL client. Note that all the SQL queries you want to enter, you need to enter using this terminal only. And for Windows users, MySQL client is basically a phpMyAdmin page that looks like this. To those who are wondering what phpMyAdmin is, it is a GUI based MySQL client where we write all the SQL queries to send the requests to the MySQL server. Since it is GUI based, it displays a lot of information visually for our convenience. At a first look, things might look overwhelming, but you don't need to worry about all the features at this moment. With time and practice, you will get to know each and everything. So, here on the left side, we can see the default databases that are present on the server. At the top of the page, we can see a menu consisting of various tabs. Let's again not worry about all these tabs right now. For now, we'll explore and discuss the SQL tab. Let's click on the SQL tab and see what happens. On clicking the SQL tag, we can say the layout below the menu bar has changed. We are concerned about this text box because here we will enter all our SQL queries and using this Go button, we will execute those queries. Let's try our first SQL query to see all the databases present on the server. For this, we use show databases query followed by a semicolon. Click on Go. And here we can see all the databases present by default on the server. Congratulations on running your first ever SQL query. Notice that the databases listed on the left side and the ones we fetched are the same. Again, I will repeat that all SQL queries end with a semicolon. So please make a note of it because as a beginner, we tend to miss these small details while writing a query. Moving on, SQL is case insensitive. This means we can enter SQL queries using uppercase or lowercase or even combination of both character cases. Let me show you this with the help of an example. So a few moments ago, we used the command show databases to see all the databases that are present on the server. Even if we enter the same command without worrying about character casing like this, we will still be able to execute this command. See, we can still fetch the databases. Isn't it cool? Although we can write SQL queries using any character casing, but I would still recommend and advise you to follow only one pattern as it looks more clean and professional. Next, let's see how we can create a database in MySQL. To enter a new query, we need to click on the SQL tab. Wait, let me show you another way to enter a new SQL query without clicking on the SQL tab. We can enter the new SQL query from this same screen from where we executed the last SQL query. And to do this, we use this edit inline option. This option allows us to enter SQL queries without clicking the SQL tab again and again. Pretty convenient, right? Proceeding further, to create a database, we use the create database command followed by the name of the database. In this case, we have taken the name of the database as college. Now, let's click on Go. We can see the name of this newly created database college on the side panel here, where all the databases present on the server are listed. If in case you are unable to see the name of the database on the side panel, you need to refresh the browser. Now, how to create a table inside a database and how to edit data in an already existing table are something we will cover in the upcoming topics. Now, as a developer, we might have to work on several databases at a given time. So, say apart from the college database, we have demo 1, demo 2, demo 3 and demo 4 databases. Let us create them first. Now look carefully, this is interesting. Instead of creating these databases one by selecting the edit inline option, we can add all the SQL queries at once but in different lines. Here we have entered the create database demo 1 ending with a semicolon. When we end any query using a semicolon, it means that the query is closed and there is no extension to it. Now in the next line, if we add the queries to create the databases like this and click go, it will create all the databases at once. Isn't it cool? So apart from some default databases, we have 5 new databases. Now we want to specifically work on the college database. So how do we select the college database only from the pool of all these databases? Before this, let's check which database is selected. For this, we enter select database, SQL query followed by open and close parenthesis, and let's not forget to add the semicolon. This SQL query shows the database on which we are working. If we run this, we can see the output as null, and null means nothing. This means we have not selected any database. Now, to select a database on which we want to work, we enter the use command followed by the name of the database, which is college. Once we run this command, we won't see any visible output. But to be sure that we have selected the college database, we will again enter the select database query. In the output, we can see that the college database is selected. Now, there are too many databases present and we know that we are not going to use a few in the future, like Demo 1, Demo 2, Demo 3 and Demo 4. So how can we delete these databases? To delete a database, we use drop database SQL query, which is followed by the name of the database. Similarly, as we did earlier, we can write multiple SQL queries at once to delete these databases like this. And here we go. All these databases are deleted and we can no longer see the databases on the left hand side panel. Again, for some users, if the names are still visible on the left side, you need to refresh the web page. In the next topic, we will learn SQL queries that deal with the tables and we will be using the college database for the same. So stay tuned, but up next is a quiz. All the best. After going through this video, you will be able to explain different components that we associate with every attribute of a table. Hi, welcome back to another exciting topic on SQL queries. In the previous topic, we said that SQL queries deal with 3 categories. And we also explored in detail the SQL queries that deal with databases. In this video, we will explore SQL queries that deal with tables. To understand these SQL queries, let us revisit our students table example from the topic 2 of this module. In this table, we defined 4 attributes: name, registration number, gender, and department. Now, say 3 new students have joined the college and we want to put their corresponding data in the table. And for that, we need to be certain about a few things. First, the table in which we want to put this data must have relevant columns or attributes. In our case, we have the attributes name, registration number, gender, and department to put the respective data. This will allow us to put the data appropriately. That is, in the name attribute, we will add the name of the student. In the registration number attribute, we will add the student's registration number. In the gender attribute, we will add the gender of the student. And in the department attribute, we will add the department of the student. Now, there are 3 components that we associate with every attribute of the table, and these are data types, constraints, and a default value. Let us understand them in detail one by one, starting with the data types. To understand it, let us again come back to our students table example. Let's say the registration number has a pattern 123001, 123002, and so on. It definitely shows that it will store only numbers which are int or integer data type. To ensure that the registration number attribute does not store any non-integer values like 123 ABC, we set the data type of this attribute as integer. So in case by mistake while entering data, we try to enter a non-integer value in the registration number attribute, MySQL will throw an error. Now that you have understood the significance of data types, let's discuss some of the most common data types that are int, float, varchar, and enum. Let us understand them one by one. Int data types, as already discussed, means integers. Int data types can have positive, negative, or 0 as values, but not decimal values. So, the values which we have entered in our table in the registration number attribute are int data type. Now, let's say we want to add the CGPA of students like 7.3, 8.5, 6.2 in our table in a new attribute, CGPA. Can we add this in our table using the int data type? No, because as discussed, int data type does not take decimal values. So, to add values in decimals, we use float data type. To specify a float data type for an attribute, there is a unique way. We first specify the total number of digits, and then after a comma, we enter the number of digits that we want after the decimal point. So, if we want to add the CGPAs such as 7.3, 3.5 and 6.2, we will specify it as 2, 1. This means a total of 2 digits can be entered and there is 1 digit after the decimal point. Note that we cannot add negative values using float data type. Now, a quick question. How will you specify the float value to enter value as 999.99? The answer is displayed on the screen. See if it matches with the one you have calculated. Next, we have the data type varchar that is used for texts. So, wherever in our table we want to add the value as text, that is for the attribute name, gender and department, we define the data type as varchar along with the maximum length of the text we want to accommodate. Here, the maximum length of the text we have taken is 255 characters because we are assuming that the name, gender and department of the students cannot be of more than 255 characters. As we discussed earlier, SQL is case insensitive, so it does not matter if we write varchar in uppercase or lowercase, but make sure that you should follow one pattern only as it looks clean and professional. But always ensure that the database name, the table name and the attribute name should be written exactly the way they are defined. And lastly, we have enum that is used when we want to choose from a list of permitted values like yes and no, true and false. Let us say in our table we add one more attribute, scholarship awarded. That tells us whether the student has received a scholarship or not. If we assign this attribute enum data, it will only take yes, no or true false as values. There are many more data types, but these 4 are sufficient for now to work with. Now let us move to the next component, constraints. They are used to specify rules for the data in a table and are optional. In this training, we will explore only 4 commonly used constraints that are not null, unique key, primary key and foreign key. To understand all of these constraints, let us come back to our example. Suppose we want to add one more attribute in our table where we can add the serial number in this table. Defining a not null constraint for this attribute means that this attribute cannot contain any null value. If you remember, null means nothing and defining not null means that this column will hold some value but null. The not null constraint does not help us to add the data. Rather, it enforces a rule that is this attribute cannot have a null value. Next, we have unique value. When we specify this constraint for an attribute, it means that the column must contain all unique values. For example, in our table, what if we add the serial number as 1, 2, 3 and so on for all the students? Do you think that these values are unique? Yes, because for each record, we are assigning a particular number that is not repeating anywhere in the same attribute. There can be multiple attributes with unique constraints like email, phone number, etc. etc. Next, we have the primary key. It is used to uniquely identify a record in a table. When we assign an attribute to be a primary key, it automatically makes that particular attribute unique and not null. Primary key constraint is very similar to unique key. The difference is very minute and we will discuss it when we discuss the concept of foreign keys. Note that for a table, there can be only one primary key. For example, in our table, we make the serial number attribute as the primary key, which will make each record unique in a table. Now suppose if we want to make the name attribute as the primary key instead of serial number attribute, do you think it is correct? No, because multiple students in our table might have the same name, which does not make it unique and can refer to multiple records at a time. Next, we will move to the fourth constraint, that is foreign key. Now this is something we will cover later in this module as we need to first understand a few more concepts related to it. Now lastly, we will discuss the third component, that is default value. This means while adding a record in the table, if we don't specify any value for a particular attribute, it will take the default value if it has any. So for example, in our table, let us define one more attribute, number of compartments, in which we have listed the number of compartments a student is having. Some of you may know compartment as backlog, they both mean the same. If we define the value as 0 for this attribute and even if we don't specify the value for this attribute while adding a record, it will by default add the value as 0 for that particular record. Don't worry, we will see all of it with examples in the next video. With this, we have covered all the components that we associate with every attribute of the table. In the next video, we will use SQL queries to understand and practice all these components in detail. So see you then. Bye-bye. After going through this video, you will be able to create a table in a database. Hey, welcome back. In the previous video, we theoretically understood these components. In this video, let us practically understand them using SQL queries. So let's get started. By now, I believe you have remembered our very first step, that is, we need to start MySQL. If you are a Linux user, open the terminal and enter MySQL u root p to start MySQL. And if you are a Windows user, you need to start MySQL using XAMPP control panel. Previously, we created a college database. We will use this database and continue to work on it in this video. If you have deleted this database earlier while practicing, I would recommend you to first create it so that you can execute the SQL queries which I am about to show you. As we will be working on the college database, we need to select it first. We will enter the use college SQL query to select the database. Now, there is nothing inside this database, that is, we have not created any tables inside it. To be completely sure, we have an SQL query that shows up if a database contains any table or not. For that, we enter show tables SQL query. If we run this query, we can see that it returns us an empty list, which means there is no table inside the college database. So let us create our first table inside this database. Now, before we create a table, always make a rough picture on how you imagine your table should look like. This will help you to have a clarity on primarily two fronts. First, it will give you an idea of how many attributes you want to use in your table. Second, it will help you define the data type, constraint, or a default value that you may want to specify for each attribute. So, if I imagine a table inside the college database, it will be a student table. So, we can name this table as students. Next, I would like to think of the attributes that may go inside the table. Well, we have already discussed in detail what attributes might go inside this table. There can be a lot more attributes apart from these which we can add. So to keep things simple, let us take the attributes as S number, name, registration number, gender, department, and number of compartment as the attributes. Well, we all fear this one, don't we? So, based on this rough picture of our table, let us create the same using SQL queries. In MySQL, to create a table, we use the create table command, which is followed by the name of the table. Here, we want the table name as students. Next, inside the parenthesis, we will define the attributes and its components. We will start by defining the name of the first attribute, that is serial number. After this, we will specify the data type. I want it to be a number. So, we will add int. Also, we will add a constraint not null for this attribute. We will add one more command, auto increment, which means that the value for every record in the serial number column will be automatically assigned even if we don't specify any serial number value. Now, to enter details for the next attribute, we add a comma to separate them. Notice carefully that I am adding the queries in multiple lines. I'm doing it on purpose to make it look more neat and clean. So in the next line, let us add details for the next attribute name. The name of the students is going to be a text. So we will specify varchar data type and not null constant. I'm assuming that no student will have a longer name than 255 characters. Using a similar approach, we can add the details for the remaining attributes. In our SQL query, there are two more new things to notice. The first is this default value and the next is the primary key. For the number of compartment attribute, we have specified the default value as 0. This means that even if we don't define any value, it will be assigned 0. And we have defined the primary key as serial number attribute. This means that the serial number will help us uniquely identify each record in a table. To summarize, the syntax is simple. Create table, table name, then the description of the table goes inside the first bracket. In the description, we specify all the attributes with their data types, constraints and default values, separating them with a comma. We specify the primary constraint at the end. Now, let us execute this query and we can see that the table students is successfully created. If we enter the show tables query now, we can see the table and the attributes here. One more thing, If we ever want to view what components we have defined for the attributes, we can check them very easily. We just need to enter DESC followed by the name of the table, which is students. This query will show the detailed description of the table students, where we can see the various components for each attribute. Well, that was all about creating a table in this video, where we created a table students having multiple attributes. In the next video, we will see how we can alter data in an existing table. So stay tuned. After going through this video, you will be able to alter an existing table in a database. Now that we have created a table students inside our college database, let us see how we can alter the data of this table. But before this, we need to first understand why we need to alter data. Suppose in our students table, we have added the name of the student incorrectly, which will affect the data. Now it is not possible and feasible at all to create a new table for every incorrect entry we make. So to help us correct the mistakes or to add and alter data in our table, we have an option to alter the data. If you are wondering how, let us have a look at different ways through which we can alter the data in a table. The first way is by adding a new attribute to the table. The second way is by deleting an existing attribute from the table. The third way, we can modify an already existing attribute like changing the data type, constraint, etc. Next, we can change any existing attribute to a new one with a new name. And lastly, we can rename the table itself. So let us take our students table and see how we can alter the data using SQL queries. We will start with the first way, that is adding a new attribute to the table. Let's say we want to add the semester attribute in our table. To do this, the SQL query is easy. We use alter table followed by the name of the table, which in our case is students. Then we write add, then the attribute name, which is semester, followed by data type constraint and a default value like this. Let us run this query. The attribute has been added successfully. To confirm, let us see the detailed description by entering DESC students SQL query. We can see the new attribute here with all the details. Now, let us explore the second way, deleting an attribute from the table. We will delete the semester attribute which we added moments back. And to do this, again, the syntax is simple. We will enter alter table followed by the table name. And as we are deleting the attribute semester, we will use drop followed by the attribute name. Let us run this query. And the attribute has been dropped. To confirm, we will check the detailed description. So, by now you have seen two SQL queries using which we altered the data of the table. Both the SQL queries are starting with the command alter table. This means that whenever we want to alter the data of any table, the SQL query must start with alter table command. So please make a note of it. Next, let's see how we can modify an already existing data from the table students. Let's say we want to change the default value of number of compartments to 1 from 0. To do this, we will use alter table followed by the table name. As we are modifying the data, we will use modify followed by the attribute name in which we want to make the change, which is again followed by the data type, constraint, and updated default value. Now, I won't be executing this query as I want you to execute this and all other queries that we will discuss later in this video on your own. So make sure that after this video, you execute all the queries one by one and observe the output on your own. Next, we will see how we can change the attribute name. Say, for example, we want to change the attribute name number of compartment to compartment. To do this, this will be our SQL query. Just pause the video and try to understand this SQL query on your own. Again, we started with the alter table command followed by the name of the table. Then we have change as we are changing the name of the attribute followed immediately with the old name of the attribute and then the new name of the attribute, which is then followed by the data type, constraint, and default value. And lastly, let's see how we can rename the table. Say we want to change the name of the table from students to students college. To do this, we will enter this SQL query. And if you run this query, you will see that the table name will get changed to students college. So this is how we can change the name of the table. For now, let us revert to the same name of the table, that is students. So this was super fun. We learned different ways to alter the data in a table. Up next is an exercise followed by a quiz. See you soon and all the best. After going through this topic, you will be able to insert, fetch, update and delete records from a table using SQL queries. Hello and welcome back to the next topic of this module. Until now, we have introduced what databases are and we have learned how to create tables and alter them with the help of SQL queries. Now, we will understand how to add data or records in the table we previously created. Keeping the momentum in this video, we will explore the SQL queries that deal with records. That is, we will see how we can fetch, insert, update and delete any record from a table. And to do this, first we will open the MySQL client. Let's begin now. So first, we'll open the MySQL client. You already know this, right? We have followed these steps a number of times till now. But let me still remind once again. For Windows users, to open MySQL client, you have to first open the XAMPP control panel and start MySQL and Apache services. Then click on the admin button next to MySQL. This will open the phpMyAdmin client on our web browser. Now, click on the SQL tab. If you are a Linux user, to open the MySQL client, enter this command mysql u root p. In the previous topics, remember, we had created a database college. We'll be working on the same database. To select this database, we need to enter a query. You have already studied this in the previous topics. Can you name the SQL query which we will use to select the college database? If your answer is use college, you are right. Also, in the previous topic, inside the college database, we have already created the table students. We will be inserting our records in this table. Let us quickly look at the detailed description of the table to recollect how it looks like. So, let us understand how we can insert a record into a table. To do this, we have insert into command followed by the name of the table. Now, as we know, a table has attributes, that is the columns. So, we must specify the name of the attributes inside which we want to insert the records. So, in our query, after the name of the table students inside the parenthesis, we will specify the attributes like this. Till here, one part of the query is complete. That is where we want to insert the data. Now, the next part of this query defines the values we want to add. Let us have a look. So, right after this part of the SQL query, we use values followed by the values which we want to insert in the name, registration number and gender attributes respectively. In our case, the values are Saurav, 123007 and male. This query might seem big and difficult to understand, but believe me, once you understand the logic, it becomes pretty simple. Also, note that the values are added within inverted commas, that is, the name and gender of the student. This is because the data type of the attributes in which these values will be added is varchar. And for attributes in which we specify data type as varchar, except string values, the values are added within inverted commas. Before we move forward, here is a quick question for you. Why have we not put the registration number within an inverted comma? You can pause for a moment and think about the answer. Let us continue and click Go to execute the query. To confirm if the record has been successfully added, we will click on the students table from the left panel. So yes, we can see the record has been added to the table. There is an alternate syntax to insert a record to the table in which we do not need to specify the attribute names. Let us have a look at the syntax first. Here, again, we have used insert into to insert the record followed by the name of the table. Notice that the table name is directly followed by the values which we want to insert. We need to be careful while adding these values as they need to be in the exact order in which the attributes are defined in the table. Now, a few values are added inside inverted commas, and the reason you are already aware as discussed earlier in this video. Click Go, and if we click on the table from the left panel, we can see the record has been added to the table students. Now, that was all about inserting data into the table. Now, let us see how we can fetch records from the table. Fetching data using MySQL is equally simple and interesting as inserting the data. There are two ways to fetch data. One, we can fetch all the data from the table at once. And to do this, we use select command followed by the name of the table. The asterisk selects all the attributes from the table students like this. And the second way is to fetch only specific data. To fetch particular attributes, we need to replace the asterisk with the name of the attributes we want to fetch, followed by the name of the table. So in this case, we want to fetch records of the attributes name and registration number from the table students. And if we look at the output of this SQL query, we can see that only the records of these two attributes are fetched. Let's make fetching the data more interesting. This is our table in which we have all our data stored. Let's say we want to fetch only those records in which the number of compartments are greater than 0. Can you guess which method will you use to fetch the data in such a case where we have some condition? Well, we won't be able to fetch the data using any of the above methods which we discussed earlier. So what we will do is we will make slight modifications to our existing SQL query. First, we will write an SQL query to fetch all the records like this. Then we will add a clause where followed by the condition that the compartment should be more than 0. A clause applies a filter on our existing SQL query based on the condition provided. Let's check the output.
We can see two students whose compartments are 1.
Apart from the greater than operator in our SQL query, we can use other operators like equal to, not equal to, less than equal to, greater than equal to get the desired results. But the syntax should be the attribute name then operator followed by the value. We can even combine two conditions using and or operators. The syntax is simple. We will enter our first condition followed by either and or operator, which is followed by the second condition. This SQL query comes handy when we have a lot of data and are looking for some particular record. Next, we have another clause, order by, using which we can fetch the records in either ascending or descending order. Here, we have this query in which we have used the order by clause. This is followed by the name of the attribute where we want to fetch the records. And the attribute name is followed by ASC, meaning in ascending order. So, this SQL query will display the records in the ascending order of student names. Let us confirm by running this query. Here we go. We can see the names of the students in the ascending order. Suppose while inserting a record, we made a typo in one of the entries. So using an SQL query, we can update any record we want to. To do this, we use the update command followed by the name of the table. Then we use set to assign a new set of values to the attributes for which we want to update the information. Here, for understanding purposes, we are taking the attribute as registration number and compartment. So far, this part of the query only tells us what information needs to be updated, but it does not tell us for which record we need to update this information. So, in our SQL query, we use the where clause and specify only that record for which we want to update the value. We have taken the record as serial number 2. This means only for this particular record, the value of registration number and number of compartment will be updated. Note that while updating records in a table, the where clause plays an important role. If we miss this clause, it will then update all the records of the table. So, to summarize, the syntax is update table underscore name, set, then comma, separating the attribute names that we wish to update, equal to new updated values, followed by any valid where clause. Let us look at the output and see if we have been able to update the record. We can see that for the second record, the registration number has become 123010 and also the compartment has changed to 3. And lastly, we will see how we can delete any record from a table. Let's say we want to delete the record serial number 2. To do this, we will enter delete from followed by the table name, that is students, which is followed by where clause like this. This will delete only the record with serial number 2. Let's run the query and we can see that we have been able to delete the record serial number equal to 2. Again, note that the use of where clause is important because if it is not used, the query will delete all the records from the table. Hope now you have understood how to fetch, insert, update and delete records from a table. I would recommend you to add more entries to the table students and run the queries on your own as discussed in the video. Try to use a combination of various queries using and or operators and observe the output. Up next is an exercise. Make sure you create the database and table as mentioned in the exercise, as we will use the same database and table later in our training. After going through this video, you will be able to address some common problems and their solutions while creating a table. Welcome to another interesting topic, designing a database. Until now, you know how to create a table and add attributes and records into it. Suppose for a given scenario, we can create 4 different tables. But how can we know which of these tables is an ideal table? Well, in this video, we will see what should be an ideal design of a database and what attributes in a table should we define for a given scenario. To begin with, let us expand our students table example. Suppose campus recruitments are going on in a particular college. The college administration wants to store the information of all the students who are selected in a table, which is basically the placement records. So, how will we do it? First, we will create a table with a name that self-describes the information inside the table. Example, placement information can be the name of the table. Here, in this table, we can add some basic attributes like student name, department, CGPA, playstat, CTC, and the job location. Let's fill some data in the table. Note that we can add more attributes to the table like job description, email, and so on. But to understand the concepts in a simpler way, we have limited the attributes as shown in the table. Also, the college has a rule that a student cannot be placed in more than one company. And for a particular company, the CTC and location will be the same for all the hired candidates for that company. This means that in this table, we have 2 different students who have been selected by Amazon. Their CTC and location will be the same. Now, pause the video, look at the table and analyze and see if it is the best way to store the given information. This table has multiple problems and you might be able to find out a few. So let us discuss them one by one. The first problem is redundancy due to tightly coupled attributes. If we observe carefully, we can see that the CTC and location attributes are tightly coupled with the playstat attribute. That is, for any value of playstat, we have fixed values for both package and location. We know for any value of playstat, we have fixed values for both CTC and location. For example, in the case of Amazon, for every student they hire, the package remains 14.2 LPA and the location remains Hyderabad. This means if any student of the college is hired by Amazon, we automatically know the student's CTC and job location. Now, this will be true for other companies as well. Here, we can see this only for Amazon because that's how we have taken the sample data. So, we see that the package and the location attributes contain information that is unnecessarily repeated for every record in the table. This means that this data is redundant and redundancy can lead to mistakes. Let us see how. Suppose Amazon changes the location to Chennai from Hyderabad. This means we have to change all the records corresponding to Amazon, and even if there is a single record left, it will lead to wrong results. The next problem is incomplete information. Let's say some other companies like Google and Facebook also visited the campus but could not hire any student. Do you think we can store this information in the table? We can, but that is not an elegant way to store this information. Also, there might be some students who appeared for the placement interviews but due to any reason were not placed. Again, this information we can store in the table but not an elegant way to store. Now let's say a company found later that one student Ajay has used unfair means to crack the placement test. So they disqualified the candidate. This means that the student is not placed and we need to remove the corresponding record from the table. This will also delete the information that the company had come to college for placements. So what should be the solution to these problems? To address these problems, we need to break the table into smaller tables, one for each entity like this. Now, instead of maintaining placement information in a single table, we are keeping information of students and companies separately in different tables. This makes the information more flexible to use. Using these tables, we can now add information about those companies who visited but did not hire any student. And also, we can store information of the students who appeared for placement interviews but were not placed. And for the student who was disqualified, we can simply remove the playstat record for that student without removing the company information altogether. So, this is how we can solve problem 2. Let's see how we can solve problem 1, that is redundancy of the data. By creating these 2 tables, we can see that redundancy of the data is also removed. Even if we have to modify the record of Amazon from Hyderabad to Chennai, we only have to make changes at one place without altering the records of the other table. So, by creating multiple tables, we can see that our database design is much more flexible and easy to work with. Now the important question is, how do we connect the records of these tables with each other? To find out, click on Next to find the answer in the next video. After going through this video, you will be able to explain what a foreign key is, connect two different tables from same database using foreign key. In the previous video, we created those two tables to store the placement information for a college. And we left the video on an interesting note about how we can connect the records of these two tables with each other. Well, we can connect the records of two different tables using a foreign key. Let us first understand what a foreign key is. A foreign key is an attribute in a table that refers to a primary key attribute of any other table. The foreign key attribute can contain values only from the primary key attribute it is referring to, and it acts as a constraint. Let's simplify this definition using the tables we have created. Here, the name attributes in both the tables can act as the primary keys with the assumption that the names in these attributes are unique. And the placeStat attribute in the students table can act as a foreign key to the name attribute of the companies table. This is because the values in both these tables are the same. Also, the placeStat attribute cannot contain any value that is not present in the name attribute of the companies table. We already know that a primary key is used to uniquely identify a record in a table, and the foreign key attribute contains values only from the primary key attribute it is referring to. Thus, foreign key is used to uniquely identify a record from the other table. Let us create an ID attribute for these tables. Can you guess why we created this attribute? If you remember, we discussed that in every table we should create an ID attribute as a good practice that should contain auto-incremented values. The foreign key will now refer to the ID attribute of the companies table, and it should contain values only from this ID attribute. So, the companies' names from the students table should be replaced by the companies' IDs. Now, the foreign key follows a certain naming convention. That is, it should be named as the name of the table to which the foreign key is pointing to, and the name should be given in a singular form. So, following this convention, we have a companies table, but we have to use singular form. This will make it company followed by underscore. Next will be the name of the attribute to which it is pointing to, which in this case is ID. So the name will be company underscore ID. Now let us look at the foreign key syntax. There are certain constraints which we can apply to foreign key attributes while creating a table. This is because the constraints will restrict the foreign key attributes to have values only from the primary key attributes they are referring to. And if we try to add any other value, it will not accept and throw an error. Let's see the SQL queries which we can use to create these tables. Here we have two tables. Can you guess which of these we need to create first? We will have to create the companies table first and then the students table. This is because while creating the students table, we will have to define company underscore ID as the foreign key. And for this, we will have to set the reference attribute, which is the ID attribute of the companies table. So, the companies table must be present before we create the students table. Note that the tables I am about to create are in a new database, College 1. So please make a note of it. Now, to create the companies table, we use this SQL query. This is simple and straightforward. Here, we have 4 attributes and we have defined the ID attribute as the primary key. Let us now look at the SQL query we can use to create the students table. Here, in this query, we have defined the company ID as the foreign key, which is referencing the ID attribute of the companies table. Note that after the constraint, the attribute name is defined inside the parenthesis. So, this is how we can define a database for a given scenario. In this video, we designed a database by creating multiple tables and understood their SQL queries. Note that we had certain restrictions while creating these tables. If these restrictions would not have been there, the design of the table would have been completely different, which we will discuss in the next topic. Now, as an exercise, create the tables, companies and students in a new database, College 1, and add the required attributes and records as shown in this topic. Hope you had fun watching this video. Up next is a quiz. All the best. After going through this video, you will be able to explain different types of database relationships, list down the steps involved to create an ideal database design. In the previous topic, we saw an ideal database design that was based on certain restrictions. In this video, we will see how we can always get an ideal database design. And for that, we first need to understand database relationships. Database relationships, in the simplest terms, means the association between two tables. It is of three types: one-to-many relationships, one-to-one relationships, and many-to-many relationships. Let us first understand the one-to-many database relationship using the college placement example. We know that these two tables are associated with each other as companies hire students. Here, we can see that one company can hire multiple students, but only one student can be hired in one company, which was due to the restriction imposed by the college. So, in one direction, a single record from one table can only refer to one record from the other table. Whereas, in the other direction, a single record can refer to multiple records from the other table. This is why this example follows one-to-many relationships. And for such database relationships, we add a foreign key to the table which has multiple records referring to a single record of the other table. This is because foreign keys must be able to uniquely identify a row from the other table. Hence, we have a foreign key on the students table as there can be multiple students referring to one company. Next, the second type of database relationships we have is one-to-one relationships. To understand this, let us take another example. We have two tables in which we have information about the Indian states and their chief ministers. Here, one state can have only one chief minister at any given time. Also, one chief minister can only be the chief minister of one state at any given time. In both directions, a single record refers to a single record from the other table, and this makes the database relationships as one-to-one relationships. Now the important question is, where do we add a foreign key in such cases? In case of one-to-one relationships, we can add a foreign key to either of the tables like this. Just make sure to follow the naming convention. It is entirely our preference to which table we want to add the foreign key. We can even choose to combine these tables into one, and that would not create any redundancy and incomplete information. It completely depends on what all attributes we want to store. If we have both state heavy and chief minister heavy information, then we must have two separate tables. Otherwise, we may choose to combine the tables. Also, based on which information dominates, we may choose the table name accordingly. Lastly, we have many-to-many relationships. To understand this, let us take another example of a cab rental service company. Here, we have two tables, drivers and customers, that stores information of the drivers and the customers and the rides they have taken. We can have more attributes for these tables, but for simplicity, we have only considered these attributes. Also, let us assume that for now the company has not started ride-sharing service. Here, a driver can offer services to multiple customers one at a time. Also, a customer can avail services from multiple drivers one at a time. So, in both the directions, a single record can refer to multiple records from the other table. This makes the relationship as many-to-many relationships. Now, again the same question. In which table should we have the foreign key? Let's say we have this data for which we want to do the mapping. This data tells us which driver has offered services to which customer. Using this data, let us add a foreign key to the customers table. Victor offers services to Tarun, so we will map Victor's ID with Tarun. Aditi offers services to Rajat, so we will map Aditi's ID with Rajat. Similarly, we will map Raja with Nishant. Now Aditi offers services to Nishant, but we cannot map Aditi's ID with Nishant anymore as Nishant is already mapped with Rajat. So is there any way we can add the remaining data? Pause the video and think for a moment. Well, you might have thought that we can probably add new rows for the remaining mapping. But does it solve your problem? Can you guess what is wrong here? Well, the customers table has repetitive data. This means it contains redundant information. Now, let's put the foreign key in the drivers table. If we again map based on the given information, we are again stuck at this point where we won't be able to map Nishant's ID with Aditi, as Aditi is already mapped to Rajat. Even if we add new rows
for the remaining data, it will lead to redundant information. This means we cannot have a foreign key in either of these tables. So what is the solution then? Any guesses? In such cases, we can have a mediator table to connect the given two tables. The mediator table should be named as table 1 underscore table 2, which in this case can be drivers underscore customers or customers underscore drivers, as there is no specific table 1 and table 2. The mediator table can also be named as rides, as it has ride specific information. This table contains foreign keys to both the drivers table and the customers table. We can see that in this table there is no redundant and incomplete information. And whenever we want to fetch any record, we need to connect all the three tables. Now let us have a look at the relationship of the mediator table with the tables drivers and customers. Can you guess what will be the relationship in both these cases? Think for a moment. It's pretty simple. In both the cases, it will be one-to-many relationships. This is because a driver may have multiple rides, but a ride will have only one driver. And a customer may have multiple rides, but a ride will be associated with only one customer. Since it is impossible to represent a many-to-many relationship directly between two tables, we created a mediator table to have a one-to-many relationship with the original two tables. So let us quickly summarize how to get an ideal database design. First, identify every entity we can think of in a way that each entity stores only one type of information. The moment we realize an entity is storing information of more than one type, break it further down. Second, create a table for every identified identity and add relevant attributes to them. Next, for every pair of tables, identify if they are related. If yes, find the type of database relationship between them. Once the relationships are identified, put the foreign keys at the right place to properly represent the relationships. And if required, create a mediator table. Next, add some dummy data into each of the tables. See if there is any data redundancy. If we can find any, this means that there is a scope that the table can be broken down into smaller ones. If not, we are ready to go. Lastly, open MySQL client and write queries to create the tables. So that's it for now in this video. Hope you had fun watching this video. Up next is a quiz. All the best. After going through this video, you will be able to apply join queries to fetch data from a table. Hi, welcome to the next topic of this module. I'm sure you are learning a lot of new and exciting things and are having fun. Let us see what we are going to learn in this topic. Imagine your next semester is going to start. Now, before the semester commences, you have an option to select a timetable on your own. You can see what subjects you are going to study by simply clicking on the Show Subjects button. Similarly, you can also see the details of the teachers and their available time slots by clicking the respective buttons. See how easily, with just a click, you are able to fetch all the information from the database, which is going to help you create your own timetable. But what is really happening behind the scenes is that your every action is linked to an SQL query. Means, if you want to see the list of subjects and to get the same, there is an SQL query being executed in the background that is fetching the results from the table where all the information is stored. So in this video, we will see how we can write SQL queries that help to fetch data from the database or tables. To understand this, we will continue using our college placement example. So let us see how we can fetch data from multiple tables using SQL queries. Let's say we want to get the job location of Navjot. To do that, we have to look at the data from both the tables. First, from the students table, we will get the company underscore ID of Navjot. Then, from the companies table, using the company underscore ID, we will fetch the company records that will include the job location. So for these two steps, we have two SQL queries. The first query, that is select company underscore ID from students where name equal to Navjot, will fetch the company ID of the company where Navjot is placed. And the second query, select location from companies where ID equal to 4, will fetch the job location of that corresponding company ID. Pause the video and have a look at these queries carefully. Did you notice something interesting? If we look carefully, both these queries are dependent on each other to fetch data. The second query is dependent on the first query, as the first query will fetch the value 4, which is then used in the second query.
So, to simplify things, we have an alternate way to fetch data, and that is using join queries. The idea is to virtually combine all the tables into one big table and fetch the data from the combined table in one go. If you look at this table, you will see the name of the attributes as something.something. This is because in the join query, we refer to any attribute by its table name .attribute name. So, please make a note of it. Now to create this table, we will use this SQL query. So the syntax is select something from students inner join companies. This part of the query will join the students table with the companies table. Next, we have on students.company_id equal to companies.id. Here, students.company_id denotes the company ID attribute of the students table. Similarly, company.id denotes the ID attribute of the companies table. So, the join takes place on the company_id attribute of the students table and the ID attribute of the companies table. This means it will match rows from both the tables where company_id of the students table is equal to the ID of the companies table. And the rows ID which do not match with any row on the other table will be added as it is. Once the tables are combined, filters are applied using the where clause. This part of the query will only fetch the row whose students.name is equal to Navjot. We can pick only those columns based on what data we need. Select companies.location will fetch the company's location of the filtered rows. This is how we can use inner join SQL queries to fetch data from multiple tables. Now before we end this video, there is an exercise for you. Remember at the start of this topic, we told you to create tables for the cab rental service company. Now, create a combined table and try to fetch a particular record using inner join SQL query. In the next video, we will learn more about join queries. After going through this video, you will be able to list down different types of join queries. In the previous video, we saw how we can merge multiple tables into one using join query. In this video, we will understand the different types of join queries. So, in MySQL, there are three types of join. The first is inner join, second is left join, and the third is right join. Let us understand them one by one using the placement information example. Here, we have two tables, students and companies. The students table stores a list of all the students studying in the college, and the companies table stores a list of all the companies that have come to college for hiring. The students table also stores the company_id denoting where the student has got placed. If the student is not yet placed anywhere, the company_id will remain null. So, let's join these two tables using the first join query, that is inner join. This is the query we will use. Here we can see that we haven't used any where clause. And by using the select, we are fetching information from all the attributes. So, this query will fetch us this data. If we compare the data of this table with the data of the previous tables, we can see that the information corresponding to Sanjay is missing. Also, the records from the company table that corresponds to Google and Facebook are also missing. This is because we have used inner join now. With inner join, only those records which have at least one associated record in the other table are fetched. For example, Ajay is associated with Samsung, Rahul is associated with Microsoft, Mohammed is associated with Amazon, and so on. But Sanjay has no company record associated with him. That is why the record that corresponds to Sanjay is not fetched in inner join. Similarly, only those companies which have associated records in the students table are fetched. Like Samsung is associated with Ajay, Microsoft is associated with Rahul, Amazon is associated with Mohammed and Mithali, and so on. But Google and Facebook are not associated with any record in the students table, and that is why the records that correspond to them are not fetched using the inner join. Now, let us see what would be the output if we would have used left join. So in the syntax, we will replace the inner join with left join. Let's have a look at the output. Here in the table, we can see that we have the sixth extra row corresponding to the information of Sanjay. But still, the table does not include the records that correspond to Google and Facebook from the companies table. This is because the left join includes all records from the left table, irrespective of whether they have any associated record in the right table. That is why it includes the record that corresponds to Sanjay
even though there is no record associated with it in the company's table. But for the right table, left join fetches only those records which have at least one associated record in the left table. That is why it still does not include the records corresponding to Google and Facebook. Now, you might be wondering what is a left table and right table. Well, if we look at the query, the left table refers to the one which is written first, that is, before the join, and the right table refers to the one which is written next to the join. Lastly, we will use the right join. Again, in the syntax, we will replace the left join with the right join. And on running, this query will fetch this table. Have a look at the last two rows. It now includes the records that correspond to Google and Facebook from the company's table. But it does not include the record that corresponds to Sanjay from the students table. This is because the right join includes all records from the right table, irrespective of whether they have any associated record in the left table. That is why it includes the records that correspond to Google and Facebook, even though there are no records associated with them in the students table. But for the left table, right join fetches only those records which have at least one associated record in the right table. That is why it does not include the record corresponding to Sanjay from the students table. So, this is how we can use different types of join queries to fetch records from a table. Up next is an exercise that you need to complete on your own. Note that these queries are very important. So whatever is taught in the videos, you need to practice and observe the output on your own.
After going through this video, you will be able to export and import a database in Windows OS. Imagine you're working on a project whose deadline is coming soon. Due to any reason, the code that you were writing got deleted or got corrupted. Now, this is something serious and can happen to anyone. As a developer, you might ask, is there any way around or a solution to tackle such circumstances? To answer your curiosity, yes, there is a simple way and it hardly takes minutes to solve such problems. We can always create a backup of our entire code so that in such challenging times, we can restore all data seamlessly. So in this video, we will see how to first create a backup of a database, also called exporting a database, and how to restore a database from a backup, also called importing a database. Let us first see how we can export and import a database in Windows OS. If you are using a Linux or a Mac OS, you can skip the remaining video and can continue directly with the next videos of this topic. So let's get started. Here in our phpMyAdmin on the left hand side panel, we might see a lot of database names. So the first step is to select the database for which we want to create the backup. Let us select the College 1 database, as this is one of the important databases that we have worked on extensively in this training. The next step is to export the database. So here at the top, we can see the Export tab. We will click on it. We will keep all the options as default and we'll simply click on Go. This will open a dialog box like this. Click on OK to download the SQL file. The SQL file is the backup of our selected database. Congratulations! We just successfully created the backup of College 1 database. Now, if we open this file, we can see all the SQL queries used in the database. We can now use this file to restore our College 1 database whenever we want. Now that we have understood how to export a database, let us see how we can import or restore this database. But first, we need to delete the College 1 database as it is already present. You already know how to delete a database. In case you do not remember, here is a quick hint. Use drop command followed by the database name. To import a database is again a simple step and hardly takes any time. Then right next to the Export tab, we can see the Import tab. We will click on it. Again, it will show a lot of options, but for now we are only concerned about this section as it allows us to upload the file which we want to restore. So we will click on Browse and we will select the SQL file which we downloaded earlier. We will keep all the options as default and click on Go. If we execute the query, you will see an error showing that no database is selected. To resolve this error and to import the database, we first need to create a new database like this. Then we will follow the importing steps as we discussed. There we go. We can see that we have successfully imported the college database. This is how we can export and import a database without any hassle. In the next video, we will see how we can export and import a database in Linux OS. After going through this video, you will be able to export and import a database in Linux and Mac OS. In the previous video, we saw why creating a database backup is important. In this video, we will see how we can export and import a database in Linux and Mac OS. Please note that the SQL queries to import and export a database are exactly the same for Linux and Mac OS. First, we will open the terminal. Unlike in Windows OS, we do not need to open the MySQL client to export the database in Linux and Mac OS. To export a database, we will enter this query, that is MySQL -u followed by MySQL username, which is root. Then -p database underscore name, which we want to export, then greater than followed by the name of the file in which we want to store the backup. This will create a file library.sql in our current directory. Note that here the library database is a random database that I have created to explain the concept of importing and exporting a database. And to confirm the same, we can enter is command. Yup, we can see that the file is present. If we open this file, we can see all the SQL queries used in the database. Right now there are no queries as this is a dummy database. We can now use this file to restore our database whenever we want. Let's see how. But first, we need to create a new database as the database we explored is already present. To do this, we will open the MySQL client, enter the password, and we'll enter this query to create a new database. Next, we will leave the database as we don't need MySQL to import the database. To import the database, type MySQL -u followed by MySQL username, which is root. Then -p database name where we want to restore. Then less than followed by the name of the file from which we want to restore the database. Once we hit enter, we can see that we have successfully imported the database. So this is how we can export and import a database in Linux. You can find the syntax from below the video. Up next is a module test. Make sure you go through all the topics again to revise the concept. All the best. Congratulations on completing the assignment of Module 4. In this video, we will discuss the solution of this assignment so that you can match the answer and resolve any difficulty you might have faced while completing the assignment. Your task was to design an ideal database design for which you were required to do a few things as mentioned in the problem statement. Let us discuss them one by one. We will start with entities. As a starting point, I already listed down the entities in the problem statement for which you had to identify the relationship and then the type of relationship. Let us see why we have listed these entities. The first is users. This is an obvious one as the users are going to register on the PG Life website to search for PGs. This means we need to store the user information. The next is the cities entity. This is because we are storing PG information based on cities and also we are sorting data. The third entity which we have is properties. Each property has some associated information like price, whether the PG is for female or male, etc. Next, we have amenities. If you see, we have listed amenities in the property detail page. So, it becomes easy to fetch only those amenities that are associated with the property. And the last entity is testimonials. Again, it is easy to store testimonials in the database and fetch only those to a specific property. Note that entities should not be page dependent. Just think of entities as what are the features we are going to build or store. Next, we will move to relationships. So relationships are dependent on constraints or features. For example, we discussed the training placement example where we had a few constraints from the college. And keeping those constraints in mind, we designed our database. Now what we had to do in this case, we had to identify the relationships between the entities which we have listed. As a starting point, I had listed the relationships of the user's entity with the remaining entities. So let us discuss these relationships one by one. For the users and cities, there is no relationship as we are not taking any data that is city dependent from the users. Next, we have a relationship between users and the properties because a user can mark a property as interested. Next, there is no relation between users and amenities. amenities are property dependent. Then we have users and testimonials, which have a relationship because users can give testimonials. So, the answers to these were already given to you, but you should understand why there is a relationship between these. Next, similarly, you can go through the relationships between all the remaining entities. I have added one line of explanation which I think will be enough to nudge you in the right direction. We will move to the next part where you need to identify the type of database relationship between these entities. You can find the type of database relationships in the solution document. Now, let us look at how many tables we need to create in our database. We have 5 entities, means for sure we need to create these 5 tables. Now, if you look at the type of relationships, we have 2 many-to-many relationships. This means for these two, we need to create intermediate tables. For user properties many-to-many relationship, we will create interested users properties intermediate table which will contain user ID and property ID as the foreign key. Next, for properties amenities many-to-many relationship, we will create a properties amenities intermediate table with property ID and amenity ID as the foreign key. Now for the remaining relationship where we have only one-to-many relationships, we won't have any intermediate table, but we will have foreign keys in those tables. Let us have a look at them. For users testimonials one-to-many relationship, the testimonials will have a user ID and a property ID as the foreign key. Similarly, for city properties one-to-many relationship, the properties table will have property ID as the foreign key because one city can have multiple properties. Lastly, for the testimonials table, we will have the user ID and property ID as the foreign keys. Now, based on the foreign keys and by looking at the PG Life web application, here are the SQL queries to create these tables. You can find all these queries in the solution document. In case you have not been able to create these tables, you can use these queries to create the tables and then add the data in these tables using the dummy.datasql file provided in the solution folder. Well, that was all in this video. Up next is a module test. All the best.